China just uncovered something on Mars that no one has ever seen before. Buried beneath the red dust lies the unmistakable signature of ancient sandy beaches, proof of a vast ocean with waves gently lapping against shores, lasting far longer than anyone dared imagine. While rovers from other nations scour craters and deltas for hints of water, this discovery pierces straight to the heart of Mars's lost habitable era, revealing structures hidden for billions of years that redefine everything we thought we knew about the red planet. This breakthrough came from China's bold first venture to the Martian surface. The mission, known as Tianwen-1, deployed the Zhurong rover in a region long suspected of harboring secrets from Mars' wetter past. For a debut attempt, it didn't merely succeed. It shattered expectations, delivering data so profound that it outshines years of exploration elsewhere, capturing subsurface features no previous rover had the tools to detect in such exquisite detail. Tianwen-1 blasted off in July 2020 aboard a powerful Long March 5 rocket from the Wenchang launch site. After a 7-month journey across the void, it slipped into Martian orbit in February 2021, marking China's arrival as a true interplanetary power. For months, the orbiter meticulously mapped potential landing zones, balancing safety with scientific promise. Then, in May 2021, the critical descent began. The lander detached, plunging into the thin atmosphere at blistering speeds. As it hurtled downward from 125 kilometers up, aerodynamic forces took hold, orienting the craft for the perilous entry. A parachute bloomed, decelerating the plunge, followed by the discard of the heat shield and deployment of landing legs. Sensors hummed to life, measuring velocity and range. At low altitude, retro rockets fired, hovering briefly to scan for hazards with advanced imaging. Finally, it settled softly amid rising dust plumes in the vast expanse of Utopia Planitia. In that instant, China claimed its place on Mars. Utopia Planitia was selected after rigorous analysis. Engineers demanded flat terrain, low elevation, gentle slopes, sparse rocks, and calm winds to ensure survival through entry and touchdown. Scientists, meanwhile, craved a site brimming with potential to unlock Mars' climatic history, especially clues to ancient water bodies or ice deposits. This enormous basin in the northern lowlands emerged as ideal, technically feasible, yet scientifically tantalizing, with orbital hints of past flooding and possible ocean remnants. Though an earlier mission had touched down nearby decades ago, vast untouched areas promised fresh revelations. On May 22, 2021, Zhurong rolled down its ramp, wheels gripping the regolith as it headed southward. Navigation cameras snapped panoramic views each sol, enabling precise path planning amid scattered rocks and dunes. At intriguing features, it halted for close-up analysis with specialized instruments. The mission's ambitious design integrated orbiting, landing, and roving in one go, a feat requiring flawless execution to yield maximum insight. Zhurong's payload suite was meticulously chosen: mast-mounted cameras for terrain and multispectral imaging, subsurface radar to delve deep into hidden layers, detectors for surface composition, magnetism, and weather patterns. Data flowed steadily via the overhead orbiter, bridging the vast distance despite light-speed delays. Communication rates proved reliable enough for high-resolution images and spectra. Martian conditions cooperated unusually well. No raging global dust storms disrupted operations. Temperatures in the region averaged mild for Mars, with light winds and ample sunlight relative to the planet's distance from the Sun. These factors allowed extended surface activity, turning favorable weather into an unexpected ally for discovery. So what hidden wonders did this setup reveal? Not fleeting puddles or frozen relics, but direct evidence of prolonged liquid water shaping the landscape. As Zhurong traversed nearly 2 kilometers, its ground-penetrating radar emitted pulses probing up to 80 meters underground. Echoes returned a stunning picture. Starting around 10 meters down, thick sedimentary layers appeared, sloping gently at angles mirroring Earth's coastal beaches. These sand-like deposits, several meters thick, paralleled nearby escarpments, rising toward them in classic foreshore patterns formed by waves and tides. On our world, such structures emerge where oceans meet land, sediments carried by rivers, sorted by currents, and piled along shores over eons. Here on Mars, they testify to a stable body of water enduring millions of years, deep enough to sustain wave action and sediment transport. This wasn't a brief flood or isolated lake. It demanded a massive, long-lived ocean covering northern lowlands. Buried under later debris from impacts and winds, these pristine layers survived 3.6 billion years, preserved like a time capsule. No prior mission had imaged such unambiguous beach deposits subsurface, making this the clearest signature yet of Mars once hosting vacation-like shores under a thicker atmosphere. Further radar sweeps unveiled even more. High-frequency channels captured centimeter-scale laminations in shallow sediments, indicative of water lane deposition rather than wind alone. Uniform layers blanketed buried craters, suggesting widespread flooding. Polygonal wedges detected deeper hinted at freeze-thaw cycles in a wetter epoch. These features, combined with surface duricrusts rich in hydrated minerals, paint a picture of active hydrology persisting longer into Mars' history than models predicted, perhaps into periods when the planet was cooling but still capable of liquid surface water. Zhurong's performance amplified the triumph. By mid-2021, it surpassed primary objectives, yet pressed on through extensions. It amassed over 1,000 sols of data, traveling beyond initial plans despite solar conjunction pauses. Meteorological readings documented pressure cycles, wind shifts, and even acoustic signatures, building the first comprehensive local weather archive. Composition scans revealed altered rocks, implying groundwater interactions or ice melt. All this from a solar-powered rover in harsh extremes, outlasting design lifespan amid cooperative conditions. Challenges eventually arose. In 2022, approaching winter and a dust storm forced hibernation. Sub-zero temperatures and panel obscuration prevented wake-up, as power failed to reach reactivation thresholds. Orbital imagery confirmed heavy dust accumulation, dimming hopes for revival. Yet even in silence, the rover's legacy endures, delivering terabytes of raw data that continue yielding breakthroughs years later, including the 2025 revelations of those buried beaches, strengthening the ancient ocean case profoundly. These findings elevate the stakes for Mars exploration. They confirm Utopia Planitia as a prime habitable zone candidate, where shallow coastal waters could have fostered chemical complexity essential for life. Shorelines concentrate organics, shield from radiation, and cycle nutrients, mirroring Earth's cradles of biology. Discovering such environments intact underground suggests Mars retained wet, mild conditions far into its Amazonian era, extending the window for potential habitability dramatically. China presses forward undeterred. The next chapter targets even greater ambition, retrieving samples to Earth for unparalleled scrutiny. Tianwen-3, slated for late 2028 launch, will deploy landers and ascent vehicles to gather material directly from promising sites. Dual heavy-lift rockets will carry the complex architecture, one for surface operations, another for orbital rendezvous and return. Targeting at least 500 grams, the mission invites global collaboration on payloads, fostering shared pursuit of Mars' deepest mysteries. If successful, samples arrive around 2031, enabling lab analyses impossible remotely, searching for biosignatures, dating events precisely, unraveling atmospheric loss. This could confirm not just water's presence, but life's faint echoes in preserved organics or isotopic ratios. Tianwen 3 positions humanity on the brink of answering whether Mars ever harbored biology, building directly on Zhurong's groundbreaking subsurface vistas. Imagine oceans vast enough to rival Earth's, beaches sculpted by alien waves under a ruddy sky, now proven real beneath our feet on another world. This discovery doesn't just rewrite Mars' past, it ignites wonder about futures there, where humanity might one day walk those ancient shores. What secrets still lie buried waiting for the next probe? Share your thoughts below, and let's explore this frontier together.